All right, Algebra 1, here we go. They say better late than never, but we're gonna make lemonade out of the lemon of the Edpuzzle video being available Wednesday instead of Monday or whatever it is, usually. And how are we gonna do that, Mr. Field? Well, first of all, these are questions that were missed from the people that already did the work. As you can see, some people already tried the assignments. And also, we're going to do this during class. So some people are getting 100% on the Khan Academy and struggling on the quiz. And that's not my fault. That's because they're not doing it the right way in November after all the times I've said it. So just get back to basics, all right? And it's a good time to do that because you understand the system. Now you just got to do the system. And if you don't understand it for some reason, maybe you'll have a new epiphany. Okay. So we have 3 assignments: the age word problems, systems word problems, systems word problems, and this one is a doozy. And then this quiz and unit test are not assessments. They are for you to do with the other 3 assignments. You have to do all 5. Okay, so don't not do this because it says test, because then you'll just get a 0. Okay, so do it. The reason it says test is because it is a collection of everything from systems. So for you, it's a review. All right, so let's go. Age word problems. So when we're doing the age word problems, first thing we want to do is read it. Ben is 4 times as old as Ishan and is also 6 years older than Ishan. Okay, so if you're not sure about this, then you can just say, you can put in some numbers to make sense of the problem. So let's say Ben is 32. Ben is 4 times as old as Ishan. So how old would that make Ishan? That would make him 32 divided by 4, 8, right? So that, and then is also 6 years older than Ishan. So that would mean, add the 8 plus 6, right? That's 14. Okay, so Ben, we said he's 32, but that would make him 14. So we know that's not right. But anyway, we can see that we have to multiply Ishan's age by 4 in order to get Ben's age, right? Is it not true that 8 times 4 equals 32? I hope you're saying yes, that is correct. And for that reason, we can say B equals 4I, because we have to multiply Ishan's age by 4 to get Ben's age. Or we have to multiply 4 times 8 to get 32. Now I'm going to stop saying 8 and 32 because that is not the answer. All right, because you see it didn't work out. When you add 6, you should get Ben's age. So let's see, what is Ben's age? Well, there's another equation we can write. If Ben is also 6 years older, what would that equation look like? That would be I plus 6. All right, so now we have our 2 equations. Once you have your 2 equations, you have to say, so set up equations, and then what form do you have? Do you know there's 3 forms of equations? Standard form, slope-intercept form, and point-slope form. But in systems, it's usually just slope-intercept form or standard form. And if we have slope-intercept form, we're using substitution for our solving process. If we have standard form, both of them in standard form, we're using elimination. Okay, so these are both in slope-intercept form. So I'm going to circle the mx plus b parts, and I am going to write them next to each other. Okay, this is where substitution. So we're using substitution. And then we put our variables on the left and our numbers on the right. So that's going to be 3i equals 6. So I equals 2. So Ishan is 2-year-old. So how old does that make Ben? Ben is I plus 6. So that would be 2 plus 6, or 8. So Ben is 8. Any questions? Put them in the organizer. All right. That's age word problems. Yeah, you can see Kevin is 39. Daniel is 3. How many years until will it take until? So we could do that one. You can ask about that one. All right. So Sakura, this one is system word problems. Sakura speaks 150 words per minute in Hungarian and 190 words per minute on average in Polish. She once gave cooking instructions in Hungarian, followed by cleaning instructions in Polish. Sakura spent 5 minutes total giving both instructions and spoke 270 more words in Polish than in Hungarian. Gosh. Have you ever seen the Hungarian language? It is insane. I went to Hungary once and I didn't know what I was reading. All right, but luckily they speak English too. So I don't know why she would have done it, but anyway. So do you remember that for word problems, the units are the most important words in the problem? So we have minutes. Units are the word right after the number. I have 270 words, more words. And then I have this is words per minute. Words per minute. Okay. 5 minutes. So, all right. So then how long did, so that's minutes, right? Did she speak in Hungarian? How long did she speak in Polish? So this bold tells us what our variables represent. I'm going to type it since my writing stinks. Okay, so what do our variables represent? H is going to be, this is how long minutes spoken in Hungarian. And then P, you know, I'm 50% Polish, is minutes spoken in Polish. All right. There we go. That is, and then, so then we also have words, right? And then we have words per minute. Okay, so from all of this information, we need to set up 2 equations. So if minutes is what the variables represent, then words per minute should be an equation, and then words should be an equation because those are the other units, right? So we should have a words per minute equation and we should have a words equation. So let's try that. So she spent, but I could be, I'm just thinking through. I have not actually done this problem, so stick with me here. Sakura spent 5 minutes total giving both. Oh, okay, hold on. We got a total. Anytime they tell you total, that is a key. They gave you an equation. Okay, so 5 minutes total. So we're going to have a total time equation. 5 minutes total, so that's H plus P equals 5. That was easy. Okay. Then 270 more words in Polish than in Hungarian. Okay. So then That sounds like subtraction. All right, let me just pause this real quick. Well, I'm not gonna lie, I just looked at the solution real quick. That was a toughie. Now, because it's not the easiest one, but we do have total words, okay? And so 270 more words in Polish than in Hungarian. So we know that she speaks 190 words per minute. So multiply that by the minutes, and that is the total words spoken in Polish. But she also spoke 270 more words. Oh, hold on. See, now I messed it up. That 190 goes over there because she spoke more words in Polish than in Hungarian. So we have to add 270 to our Hungarian words. This is total Hungarian words. And we have to add 270 to that to get the amount of words spoken in Polish. Okay? So that is a tricky one, and I wouldn't mind if you asked about it again in class until you just make sure you ask about these questions until you understand them. If you say, don't say, Mr. Field, that Edpuzzle video didn't help me. Say, Mr. Field, can you explain that Edpuzzle question again in person? And I'll do it. Okay, so let's put our variables on the left. Come on. 150 plus negative 190 equals equals negative 270. Then from here, how would you solve it? You would solve it. It's not writing. Solve using what? Elimination or substitution? The answer is elimination. Okay, so how do we solve using elimination? Well, we would multiply to cancel out the variable. I'm not going to go all the way through that with this one. But if I wanted to cancel out the h's, I would multiply the top one by negative 150. And then we wouldn't have to multiply anything else because then they would both be opposites. Okay, but that's what we did this week. So if you have trouble with that, you can look at the solution, post in the red section, all of that. But I want to talk about the word problems. Hey, let's do one more word problem like that because that was a toughie. Okay. Bavik bought 3 liters of milk, 5 loaves of bread, and then this is dollars. Okay. 4 liters of milk, 4 loaves of bread, $10. What are the units? We got bread, milk, dollars. So this is not too bad. And then we have month 1 and we have month 2. All right, and guess what? This kind of just goes right together. So 3 liters of milk, that's going to be 3M plus 5 loaves of bread, 5B equals $11. So 3 liters of milk times, so M equals the price of milk. And you can see how much does a liter of milk cost. And then B is the price of bread. All right, so what's month 2? Month 2 is going to be 4M plus 4B equals 10. And again, what form are both of them in? Standard form. So what are we going to do again? Use elimination. Okay. If I was using elimination here and I wanted to eliminate the m's, I would multiply the top one by -3 and by -4 and the bottom one by 3. Okay, so there we go. Couple word problems. That one went a little bit better, huh? Now, this one, there's this one question about these balloons, this helium balloon, and it's a rough one. So when we get to that, we'll go over it. But this word problem set may have infinite solutions or no solutions. So don't stress about it. Just try it, put the right questions in, and we'll go after them. At Emilda's fruit stand, you buy 5 apples, 4 oranges for $10. Your friend bought 5 apples, 5 oranges for $11. Is it possible? I do believe so. Looks like we got 5a plus 4o equals 10, and 5a plus 5o equals 11. Well, yeah. Okay, so all we got to do is use elimination, right? We can even just subtract the two systems. Subtract those. That's going to be -o equals -1. So O in orange is $1. That's $4. So then if I just substitute in 5a plus 4 times 1 is 4 equals 10. 5a equals 6. A equals 6 over 5 is at 1.2. So an apple is $1.20 and an orange is $1. B. Isn't that good? So sometimes it works out, sometimes it will not work out. Look at this. This is bad. Oh, look. Is that the right answer? No, it has no solution. Oh, we better do this one. Last question here. A fruit stand has to decide what to charge for their produce. They decide to charge $5.30 for 1 apple and 1 orange. They also plan to charge $14 for 2 apples and 2 oranges. Can we find a unique price for the oranges? Oh, okay. So A plus O equals 5.3. And then 2A plus 2O equals 14. And so if I multiply this by -2, then I get -2A, which is good, the A's will cancel, but then I also get -2O, which doesn't look like an O. But anyway, that makes those cancel. And then -2 times 5.3 is -10.60. So we get 0 on this side, and we get like, what is that, 14? It's like 340 or something. Whatever it is, it's not 0. And so these two numbers are not equal, so the answer is no solution. All right, so if they were both the same, then it would be infinite solutions. All right, so this is a great set this week because it's going to help you review and it's going to help you think about systems in real life. So let's talk about it together one by one, putting those questions in the red section. I want to see 5 or 6 red questions. If you're struggling, you need to have red questions. And then you'll get better. And if you don't, then you won't. All right, so let's get to it.